Welcome, fifth grade mathematics teachers. My name is Daryl Frost. I'm a K-5 district math coach, and my co-facilitator.
I'm Shanna Uy, also a district K-5 math coach.
Today in this Math Dive in 5, we're going to focus on place value relationships, but specifically look at strategies to build understanding of powers of 10. So we're immediately going to engage you in a task. We're going to ask that you pause the video and complete the task on your own or with a partner.
So you're going to write an equation to represent each situation. You guys can access the task, just focus on scenario 1 and 2 using that QR code or using the URL that's on the slide.
Happy problem solving.
So pause and we'll see you back here in a little bit.
So now that everyone's had an opportunity to solve these two scenarios, we're first going to focus on scenario 1. Shanna, how did you and I'm sure most of the fifth grade teachers that are engaged in this Math Dive in 5, how did you solve it?
Well, Daryl, I ended up multiplying 10 4 times, so 10 times 10 times 10 times 10, and got 10,000 houses.
So is that what you're saying there?
Yes.
Could there have been any other ways to any other equations that could have shown that 10,000 houses were claimed?
Well, I guess someone could have multiplied 10 times 1,000.
Where do you see it, the 1,000 at in that? Does that connect to that equation that's there?
10 times 10 is 100, and 100 times 10 is 1,000.
Oh, I see. So you're seeing that 10 times 10 times 10, that's 1,000, and then I have to multiply that by 10.
Yep.
I got you. All right.
So 10,000 is 1,000 times greater than 10.
And notice that there's context to it. 10,000 what?
Houses.
Okay. All right. What about scenario 2? What did you do there?
That one I ended up dividing 10,000 by 1,000 and got 10.
Oh, so then, but I have a different equation. How does that connect with what you said?
Well, dividing 10 3 times is the same thing as dividing 1,000.
Oh, so you're thinking about it as, okay, if I have 10 times 10 times 10, it's 1,000, but in this context, I'm dividing, so it's 10,000 divided by 1,000, and so each person spent.
So $10 is 1,000 times less than 10,000.
Oh, so that multiplicative comparison there, I see. And so the idea here is we want students to think about that base 10 as powers of 10, not exponents. In BEST, in grade 5, or actually I should say in K5, exponents are not addressed until students move into middle school.
I'm glad you said that, because when I saw powers of 10, I was thinking exponents.
It's only understanding them as that multiplicative comparison and multiplying by 10 or dividing by 10, not writing it
or 100
or 1,000, just that base 10. Yes.
Okay. Thank you.
That's good. Thank you for bringing that up. So take a moment just to look at this progressions with BEST in terms of place value relationships. Just take a moment. And you notice here that the big change, or let me ask you, Shanna, what is the big change from 4th to 5th grade with place value relationships?
Well, Daryl, it looks like that in 4th grade, I just did 10 times greater or 1/10 of the value. So only adjacent place values, where in 5th grade, I can do 100 times greater, 1,000 times greater, and so on. So that's definitely a big change.
That's exactly what I was looking for in an answer, Shanna. Thank you. Yes, it's multiple place value positions, and it includes decimals. So it's important that we address that, and we're going to do that today, but through the context of powers of 10. Again, powers of 10, not including what? What's that?
Not exponents.
Not exponents, that's right.
So Daryl, I'm wondering what that looks like. How do I set my kids up for success with that? Like, what strategies, what models should I use?
I'm so glad you asked that. Stay tuned. That's on our next slide.
Perfect.
So the model that we want to use, just like with all grade levels, is with place value, is begin with base 10 blocks. We want students to see that comparison, just like what they did in 4th grade, where the place value position that was adjacent to the left or right is 10 times greater, 10 times less. But now we have to think about looking at that 1 there, that 1 to the 10 to the 100. I have to think about the relationship across multiple place value positions. And so in thinking that through there, I need to be able to see that, okay, that times 10, now it's times 100, or it could be times 1,000.
Oh, so I see. So what we did in 4th grade where we built just that times 10, now we're seeing 10 times 10 is 100 and 100 times 10 is 1,000. So that is why that ones block is 1/1000th of that large cube.
Or I could say the 1,000 is 1,000 times greater than 1.
Daryl, why do we need to start with base 10 blocks if they've already done it in 4th grade?
Because it's an entry point to thinking about 10 times greater, but then they're seeing that relationship as it builds on, that I can determine the relationship between ones and thousands, or ones and 10,000s, but we want to start with 4-digit numbers.
And I guess it is different too, going across multiple place values, so I need to go back to those base 10 blocks to introduce that part.
Exactly. But you're connecting with what they did in grade 4, only multiple place value positions.
Perfect. Thank you.
You're welcome. So now 5th grade math teachers, I want you to, this is really, if for lack of better words, the meat of this place value relationship here is thinking about that multiplicative comparison with decimal values. So just like the question on the slide, what if the large cube is now worth 1 whole? What's the value of the other blocks? Shanna, help us out there.
Oh, so now I see we're changing the value of the base 10 blocks so that we can also model the decimal relationships between place values.
Precisely. So if the large cube is worth 1 whole, the flat is worth 1/10, the rod is worth 1/100th, and the cube is worth 1,000th, and that's within the limits of the benchmark, because the benchmark is to the thousandths place in grade 5.
But I can see that I can still see the 10 times relationship by using those models. Even if I needed to take that rod and put it on top of the flat,
yes,
I could do that.
Yes.
And then vice versa, going the other way.
Just like you did with multiplication in grade 4, now we're thinking about it in terms of division.
Oh,
So,
I see.
Do you see that there? Like, okay, so what is that telling us here, that divide by 10? What does that mean?
That means that that unit is 1/10 of that rod.
There you go, that
or
unit.
I can multiply by 1/10.
Right, exactly. Here, what does that mean? Same idea?
Yeah.
Oh, and you're beginning to see a what?
Pattern.
A pattern, yeah, there you go. So I could say that the small cube is 1/1000th of the large cube.
So I see we're using those base 10 blocks to explore those patterns. That will eventually move us from the blocks, but it's definitely an important starting point.
And also to connect that to equations, like using that language, okay, what does it look like in an equation? Just like we do in 4th grade.
Awesome.
So as students are anchoring or I should say, as students are building their understanding with concrete models of moving across multiple place value relationships, either to the left or to the right, multiplying or dividing, you want to anchor that knowledge with an anchor chart such as you see here. So if you look at top in green, as you're moving from the right to the left, you multiply by 10. Or at the bottom, you see there, you're moving from the left to the right, you're multiplying by 1/10.
Or it's dividing by 10.
There you go, or dividing by 10. So either way, and you want students to be flexible, and you can also, Shanna, connect that still to the base 10 model there. Let's just take a look at this number here that you see, and it's 555,555, and 555 thousandths.
That's a mouthful.
That's a mouthful, isn't it? However, did I read that
You
correctly?
did.
So if you take a look at that there, notice the instructional practice with it. What do you notice about all the digits in each place value position?
And they're the same. And I really like that because I think having all the digits the same in one number really helps me compare the relationships between those different place value digits rather than doing it across two different numbers to start.
So it's very purposeful that we have this number here, this value. So take a look at those base 10 blocks and just visualize if I have 5 thousandths or 5 of those unit cubes and I multiply that by 10, then I have 5 hundredths or 5 of those rods, and you could see that relationship. Of course, you don't see it. You got one unit cube on one rod, but you have to visualize, you know, the 5 unit cubes and then the 5 rods, or the 5 hundredths.
And then we could connect that back to the place value chart and looking at if I go from the thousandths to the hundredths, it was times 10, but what if I went from the thousandths to the tenths? Now it's times 100 and so forth.
Exactly. Again, multiple place value positions. So as we move from base 10 blocks, which allow students to develop that proportional reasoning and that 10 times greater, 100 times greater, so forth over multiple place value positions, we can start using a tool with such as place value disk. Shannon, how do place value disks come into this idea?
Well, I can see that they still represent the numbers and help us visualize it, but I don't see that 10 times greater relationship or 10 times less relationship like we do with the base 10 blocks. They're not proportional.
So it's best practice to start with the base 10 blocks, and we can also start representing larger numbers because we have to go beyond, you know, digits in the thousands place or a digit in the ones place and then tens, hundreds, thousands.
It still gives us a representation of the numbers. It's just not as proportional as the base 10 blocks.
So this number here is 770 and 7/10. Questions that you can ask: how does the digit 7 in the tens place compare to the 7 in the hundreds place? What would you expect a student to say here?
Well, I would expect them to kind of spend time exploring them and comparing them, but ultimately the 7/10 is 1/1000th of the 700s.
Or 700 is 1,000 times greater than 7/10.
Yes.
Notice how we have to be very precise with our vocabulary.
And we could connect back to those patterns on the place value chart since the discs are on a place value chart.
Exactly. So to recap everything we've done today, think about the CRA model: concrete, representational, abstract thinking. We want to begin with that concrete thinking with the tool base 10 blocks, developing that understanding, starting with what they know in 4th grade, moving to multiple place value, moving across multiple place value positions, including decimals. Then we can start working with larger numbers using the place value disk, with or without a place value chart, and then translating those the things like 70 is 100 times greater than 7/10 into different equations so that they're seeing that relationship.
And that's where you could expect explanation too for that abstract thinking as well.
And make sure we're making connections along each of these islands. That's what the bridges represent, are the connections. Well, we hope this Math Time in 5 has helped you with place value relationships in grade 5, specifically using strategies to build understanding powers of 10. And stay tuned for many more.
Thank you for coming.
Bye.